Explorers, and welcome to another video. Today we are going to talk about test data and a little bit larger data set. And I had a problem with testing Vitess. I wanted to have a data set that was large enough to actually see how the flow goes and how you can actually migrate data from a MySQL into Vitess and actually test the cluster. And of course I could use real data for that, but for testing purposes I wanted something that was pretty large but not really huge, and also I didn't want to use live data, of course. And I looked into what was available out there, and I realized that there were actually a data set from IMDB. So the movie database out there. They actually have an open data set. It's not all of their data, of course, but it's 10 million videos or 10 million movies, episodes, and so on, with all the data for that, with actors and who's writers and so on to the different movies. So I downloaded that data set and realized that it came in this tab separated values format. And I asked ChatGPT to create a Python script just to create a couple of tables for it. And I realized that it could not do it to save its life. It was really, really bad. And I said, okay, I will spend pretty much one evening, a couple of hours, and write something that can parse this data and put it into a database. Or at least create SQL statements that I could load into a database. So if we switch over to my screen here, this is my script, which parses these files. We could look at some of them. So for instance, we have the name basis. So this has some kind of name variable in the beginning here. This is some kind of ID for this name, nconst, and then we have a primary name, we have a birth year, death year, primary profession, and so on. And then we have title. Let's see, we can open that as text. Same here, title ID is some kind of ID here, but we also have an ordering, so we see that these two are the primary key for this one. So I did some check on the data and tried to figure out how to actually structure these databases. Then I created some small functions that could help me. So one of them was this wrap or null, and it pretty much just takes in this --n. So if it's a /n, then I know there's a null value. They haven't specified that particular value, so then I will return null. Otherwise, if it isn't, I will return a string, and I will replace all the characters that are these kind of they're not allowed in this kind of string variable with just one apostrophe. So I do some changes to this script here, but that's pretty much it this wrap or null does. So then I had this main script, if we start from that end, and it pretty much runs all of these functions. I start with creating a file output stream for data SQL GZ. So I want to have it packed because it will be large. It's about I think a couple of megabytes in size, packed, but it's actually gigabytes when you have it unpacked. So it gets really large if you have it unpacked. And then I create this writer to write to this gzip output stream. So when I had done that, I could pretty much write the first thing here to say that I want an UTF-8 character stream, and then new line, and then I run all these processes and I flush it out and close that stream. So if we look at the different functions here, we can start with the process title. This starts with just saying, okay, don't commit this out directly because that will be super slow. If we do a bunch of inserts and then you commit them all after each other, that will take forever. So turn off auto commit, Then start reading this title basics. We'll drop the file. We will write the table. So pretty much ID. We have a title type. We have a primary title, original title if it's an adult movie, and then start year, end year, runtime, and genres. So I write that out. Then I will check if this is the first line, and then I will just skip over the first line because that is the header, so I don't need that. Split it up in an array and then go through and write it out just with the string builder. So I get a line, insert into titles, all the values here. Then I will parse the ID. So that was the function at the top here. I'm not sure if I mentioned it. It pretty much takes the first two characters, skips those two, and then parses the rest as an int. So that will be the ID from the files, and that we saw when we opened this, that the ID is two characters and then the number. So I just said, okay, let's just use the number, much easier. And then I will go through and wrap it or null, and then I have a couple of here that I just check. If it's null, then set it to null, otherwise I will set the values. So it's a pretty simple function, and then after this we will commit it and then set auto commit to 1, and then I will add the primary key afterwards. And the reason I put that outside of the auto commit, I could have put that inside of the auto commit, but some of these had a problem where the primary key or other constraints that I added didn't actually weren't fulfilled because there were not unique values. I think all the primary keys in the tables here are fine. It's just the other constraints that are a little bit more hairy. So here we have the second one. It's pretty much the same. Create a table, insert a bunch of things, and then I have these alter table here. Add a primary key, and in this case I had a title ID and an ordering. So this was the language with the different translations. And here I also put in this little constraint that the title ID should be a foreign key into the title database and delete cascade. And the reason I put these in is that I know that we have a lot of constraints in our database, and I wanted to test that as well. The names database, all the actors pretty much, and writers and so on. This had two tables, so I create both known for and names, because it had a list of known for at the end. So if we look at the names here, at the end here you had a known for titles, and then you have a bunch of titles back here. So I wanted to put those into the database as well. So what I did was go through and insert the first value up here, and then take the name ID and insert this kind of ID table where you just map one ID to another ID in this known table, known for. And then I added some constraints down here, and I know that the known for title constraint wasn't fulfilled, so I guess that some of the actors were known for a title that was not in this data set, which is reasonable because they only gave us 10 million movies. The crew is pretty much directors and writers, and we go through those, and the same here, what title they were director or writers for, and the title weren't working there as well, but we also get all the names, so you could have a constraint for that. Episodes, and a very simple table where you just have one ID and a parent ID. So an episode were a part of another episode or a movie. So you can say that this is parent of this, and then you could put in season number and episode number. So a very simple structure for that as well. I have a couple of foreign IDs here, and those were working just fine. And principals, these are pretty much a combination of a couple of things. So it's a title where you had a name connected to that title and what that person was doing in that movie. So if, for instance, if you were an actor and the character's name was something, you will have that in this table. So if we look at the principals here, we could say that in this title, this name played an actress, which was Miss Gwendoline Hollowbook, Miss Jerry. So if you know that movie, you know who that were and what movie that were. I don't really know all of these movies, but they are pretty old, so it's very old data that we are running through here. And then we just push those in, and I created a couple of constraints for that as well. Last but not least, we had some ratings. They sent some ratings as well. So we put in the title ID and average rating and number of votes, and then just push that in with a couple of constraints. So this was pretty much it that I needed to do in order to create this data set. When I was done, I could take this file and just do a zcat, the data SQL, I think I call it gz, and then pipe that into MySQL dot user, for instance, if I want to put in as user root, and then I could have the movies database, and then it would just create those tables and push those into that database. So that was pretty much the use case for this script, and it worked pretty well, and I got a data. We could look at it. I have put it on one of my nodes here in my cluster, my MySQL drive. This is a separate drive, and then I can do a check on the commerce database. So this is the database that I read in, and if we do a sudo, so I actually read that one, we see that it actually ended up to be a 12 gigabytes in size, this database. So it's a pretty chunk of database where we can do some migrations. And I also think I might do some videos where I just create a web GUI for this. That could be a fun challenge. So I would put this code up on GitHub. So if you want to, for instance, play around and learn a little bit about handling large data sets and also creating a web GUI that could handle a lot of rows and so on, and play around with that, I think this project could be a good starting point for you. You can download these files, create SQL statements, push them into MySQL database, or even an SQLite perhaps. Just remove the constraints. That should work fine with that as well. And then you could create some kind of GUI in order to present these facts about movies and learn a lot in the process. So I hope that you found this interesting or something that you could continue playing around with. I will leave a link to the GitHub repository in the description below. I hope that you like this video. Give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you have any comments or suggestions, leave those in the comment section down below. And I really hope to see you in the next video.